How's it going? Hello. I'm Aaron from Solace. Welcome to yet another Office Hours. Bonus points if you know what our special introduction music is from. It might give you a clue about what today's Office Hours are about. So yeah, put it in the chat, put it in the comments if you know what this music is from. I hope there's some old schoolers out there like me. It is August 22nd, 2023. I'm coming at you live on LinkedIn, YouTube, and Twitter from North Vancouver. I'm in North Vancouver right now. Yeah, I'm happy to have what I think is going to be a pretty good episode. But I'm very excited to have a special guest with me. I was going to introduce him as the head of core engineering at Solace, but he recently got a promotion. So please welcome to the stream our chief architect and head of AI, Ed. Are you out there? Hey, Ed.
Hey, Aaron. Thanks for having me. Very good.
Yeah.
Very good.
Thanks for being here. Do you know what this music? I hope you would know what this music is from.
Oh,
it's been a while, but
it's very familiar. But I'm not going to throw a guess out there.
Come on! Oh, wow. Well, I thought in let's see if there's any comments here. Let's see if anybody out there knows it. Oh, we have a hello. Yeah, say hello if you're out there. I'm happy to have people out there and say. But yeah, if you know what this music is from, I'd be happy. Hello, hello, Zainab. And Mohammed. Hello. Hi. Welcome to the stream. Okay, so I'm going to leave it for a minute just to see if anybody else knows what this music is from. But yeah, today is all about demos. We're going to do a demo day. So if that rings any bells, what this music is from, put it in there. So Ed, why don't you say hello, tell people who you are, and give a bit about yourself.
Sure. So yeah, happy to be here. I'm actually downtown Ottawa right now, a little bit away from Aaron. And I've been at Solace forever, it seems, over 19 years now. I started back in the old days of pure hardware, making FPGAs and stuff like that, and done all kinds of different software stuff throughout the products. Like Aaron said, I was head of our core product development team for quite a few years, and recently moved on to doing much more technical stuff with being a chief architect and trying to focus on some AI technologies just to see what we can do with those, both internally and with our products. So yeah, excited to be here. Love to play around with our product, love to play with demos and stuff. I mean, Aaron and I have a kind of almost healthy competition of building demos within Solace, and
that's
to have us together.
That's one of the reasons why I'm happy for you to be here, Ed, is because you also like to code demos, you also like to hobby code, and maybe we'll see yours as well later today. But yeah, this music, I'm surprised no one's got it on the chat there. This music is from Future Crew's Second Reality demo, which won their demo competition in Finland back in 1993. Arguably one of the greatest demos of all time, and it blew my mind. I was in grade 11, I think, when this demo came out, and it was holy moly. It's what they can do with graphics card days, and 386s was pretty mind-blowing. All right, so we got a few people on the chat saying hello. Let's say hi. Mark, how's it going? Baris, hello, how's it going? Zainab from Pakistan, awesome, excellent. Hey, Nick from Atlanta, welcome to the stream. Tasmia, hello. Can't seem to place the music. Yeah, Second Reality, Future Crew. Go look it up on YouTube. It's an amazing demo. Hello from France. Oh, hello. Hello, Sissy. Here for the convo. Well, how about we're here for some demos? We're going to be here for, all right. So, Ed, let's do this. So usually I have my special guests do most of the presentations, right? So I've often had people from PLM. Rob Tompkins has been on here a couple of times. Usually they give the presentation. Last month we had a special demo about AWS integration that my colleague Hari did. And again, he did almost all of it, and I just had to kind of sit and commentate. But this time I'm going to drive, and Ed, you just get to kind of sit and watch. So it's a little bit more work for me. So I'm a little bit more nervous than usual. But anyway, well, hopefully this all goes pretty well. I'm going to go ahead and share my screen. So actually, before we do that, so let's talk about partition queues. So that's what today's office hours are about. Partition queues got released when? Back in April or May, I think. There, Ed?
First out in April.
That's right. And they are our kind of next generation kind of parallel processing guaranteed messaging component to allow kind of load balancing among multiple consumers, but with a lot more fanciness than our traditional non-exclusive queues, which we've had, forever. I think since probably the start of, basically since we've had guaranteed messaging, we've probably had non-exclusive queues, right?
Yeah,
And
they've been around a while.
And that's right. So yeah, partition queues. I don't know if everybody's been playing with them yet, but yeah, they were released in the 10.4 broker. So if you need at least one of those, Solace Cloud, you can sign up for a free account and play with either a 10.4 or 10.5 broker. But yeah, actually, you know what? Let me just put up this slide here. How about that? I'm going to share my screen. Share my screen. Aaron, do you have new glasses? Says Sissy. Yes, I have some new glasses. Share. All right, Ed, tell me if you can see this here.
Yeah, all good for me.
Okay, cool. Yeah, so this is I mean I've tweaked it a little bit, but this slide has been used by our PLM, by our CTO whenever we're talking about partition queues, just as like kind of how they work. So I just wanted to flash it up here, just so people have a bit of a frame of reference, right? Essentially, it's well, I don't know, Ed. Do you want to explain what partition queues are, since
Sure.
your team built this thing?
Yes, this is how you get off the hook for doing the presentation.
That's right. You have to do a few things. So
you want to hit the little slideshow button so it's bigger?
Yeah, I can do that, but it's going to pick the wrong screen probably. So
okay. Well, if you're
yeah, give me a second. I will do that.
All right, it's this little guy at the bottom.
That should work. No, keyboard shortcuts, man. Shift F5. Shift F5. Start on the same. Yeah.
All right. So anyway, partition queues. So it is another way to do load balancing through a queue. As Aaron said, we have non-exclusive queues for a long time, and a non-exclusive queue would allow multiple consumers to actively consume from the same queue, but it was just through round robin. There was no sort of intelligence about getting certain flows of data through to the same consumer. So this is a perfect example of it right here, where
this is a slide in progress, everybody. So yeah, that's why it's kind of like I got partition queues and just showing what a non-exclusive queue does there. So.
Yeah, exactly. So in the case of just a dumb kind of non-exclusive queue, if you wanted to deliver data in a load balance manner, so doing sort of horizontal scaling for your applications, and that data actually, some of the events that are going through that queue relate to each other. So, it's often the case where you'd have a big stream of events, but interleaved inside that long stream, some of them would be for the same order, like in this case, order 22. And so what you really want to have happen is for everything to do with that order to go to the same consumer, to make sure that they're processed in the same order, because there's some kind of consistency that has to be held between them. And you certainly don't want an order to go in and then a cancel to go to a different consumer, but because one of them was backed up or slow or whatever, that the cancel is processed before the actual first onset of the order, and then have it show up later and then actually be processed as if it wasn't canceled. So by having a partition queue, you can basically label events with a key, and that key would, in this case, probably be your order number or something like that. And when it goes into the partition queue, the broker will hash that and put it into one of many partitions. And the number of partitions you have will be set up by the administrator for the appropriate number that might be required to handle a certain level of horizontal scaling. So anyway, the message or the event comes in, gets hashed, gets put into a partition, and because a hash is deterministic, a later order that will come in that has that same key will go into the same partition queue, and any one of these partition queues will only go to one end consumer. A single consumer may pull from multiple partitions, but a single partition will never push to more than one consumer, more than one active consumer. You can have a situation where you have more consumers than the number of partition queues, but the other ones will just be on standby and will take over if one of the other ones fails. So anyway, it's a fairly straightforward concept. There's details in rebalancing and all that kind of stuff, but it's just allowing you to service, this consistent events that are coming in a certain order and make sure they're processed in order.
So I remember when I started. So I started working on this demo actually back in April, and it was kind of like an on again, off again thing. The demo that I'm going to be showing a little bit later today. And I remember having kind of conversations, discussions with some of our internal teammates around kind of what is the benefit of around partition queues that we want to show. And there was actually some disagreement. And so I really wanted to make sure that the demo showed both things. And that was, kind of what we're seeing on this slide. I kind of thought there's two things that partition queues gives you. Like one, if your consumers are stateful and they require like individually that they receive all related messages of a particular thing, right? If this consumer gets the new order for 22 and then say maybe holds on to that for 5 seconds before flushing it into some backend or some order entry gateway, you want to make sure that all order 22s go to the same guys. In case you cancel it, he can delete it from his state. But the other one is, even if these are stateless applications, they really don't care and they can process things, one by one by one. You might need ordering in the back end on that particular thing, right? Whatever sits behind your consumers from Solace, because Solace consumers are usually not the last hop of your data flow, right? Your Solace consumers read from Solace and then push it to a database, push it to a cloud native service, push it to disk, push it to a log file. There's always something, the Solace consumers aren't a sync. They don't just, the messages don't disappear into them, right? So maybe the consumers don't care if things are out of order or going to different places, but your backend does. So partition queues actually elegantly solves both of these things kind of at the same time, right? And that's what's kind of really, really quite nice about it.
Yeah. Well, one other thing I'd mention is that you can have multiple partition queues getting the same events. And I think that's something, partitions exist in the world of Kafka as well. And I think sometimes people have, or application teams have trouble where they're set up a topic with a certain number of partitions, but then you have different consumer groups that are pulling from that. And the number of partitions you have isn't suitable for all the different users of that data. Whereas in Solace, you can set up multiple different partition queues. You can have different subscriptions on those queues or the same. And those different partition queues can have different numbers of partitions. And so you might have one application team that wants to get this data, but they process it very quickly. They don't do a lot of analysis or whatever on it. So you can have fewer partitions there. And then on another application group, you might have a lot more partitions because they have much more heavy lifting to do. So they need more horizontal scaling.
I don't have a slide that shows that, and I really should. And kind of at the outset of writing this demo, we thought that would be something useful to show, and then it kind of got canned because it kind of made things too complicated. But to Ed's point, in Kafka, the way that they do partitioning, but not just partitioning, but destination addressing and storage are tightly coupled. You publish to a topic is the file. You read from the file, you read from the topic. But in Solace, we have a decoupled kind of concept of addressing, the topic that the message belongs to, which can be multi-level, multi-key, hierarchical, and then the queue that attracts what messages it wants by its topic subscriptions, right? So the address of the data and the location storage are two separate things. And so this is why we could have, we could have one ultra heavyweight app that has 10 partitions here, with a whole bunch of consumers reading all of that data. And you could have another app that is ultra lightweight and maybe just counting how many messages it sees, for example. And it could use a regular exclusive queue, or it could use a partition queue with only 2 partitions. And they're completely independent. And I should have a slide about that because that's a really great benefit. And maybe make the demo work like that. Actually, the demo should work like that, but you just need multiple screens to kind of show it. So anyway, it's a lot of slides. How about we see if I can get this thing running? So I actually just released a video on this. If you want to see the short version without all the rambling, it should be on YouTube. It was supposed to go out last week, kind of because I do mention this office hour broadcast. But if you're watching this broadcast, then you probably don't need to watch that video because you'll get all you need to kind of run this thing. So I'm going to go ahead and actually set it up from scratch and kind of kick it off. And hopefully it all goes kind of well. Like I said, live demos always make me a bit nervous. So let's see if I can get this to work well. So Ed, you're gonna have to kind of remind me to keep zooming in if I need to. All right. So that's usually the person who's kind of watching. That's their job. So, we got a few more people saying hello. How about I just put you on here? All right. Janu, Kumar, hello. Welcome to the stream. Thank you for joining us. We want to hear some questions out there. Hello, Asif from Pakistan. Here, I'm going to put a banner that says ask some questions. We want you to ask some questions. Partitions queue. You have Ed Funnekotter, guys, live on the stream. You can ask him anything you want. This is great. I'm very happy that you're here. All right, so to find this demo, you're going to head over to github.com/Solace Labs and search for PQ. It's right near the top because I probably just added some little check in there. And yeah, all the code is here. I got documentation on how to run it, but I'm just going to go ahead and run it right now, and you can all watch me do this. So I'm going to clone this thing. All right. You can either just download the zip file or clone it. And I got a brand new EC2 instance here. I just deleted everything off of it. All right, proof, right? So git clone, let's clone this thing. Okay, PQ demo, and I'm just gonna build it. Assemble. So this demo uses JCSMP. I started to write it in JCSMP just because I'm more comfortable and familiar with it, but I'm thinking I might actually upgrade it to our Solace, like our new Java API, a PubSub plus Java API. Maybe later. I just wanted to get it something running, and then I just kind of stuck with it. So this obviously this would work. You should be able to write this demo in any language that you want, right? Our API support for partition queues is across all the APIs at this point, I'm assuming, right? I think it must have been when we released for 10.4, right, Ed? So yeah, I could have written this in .NET or C or JavaScript, and it should have all just worked the same. By the way, one thing I didn't mention in my YouTube video that I posted was that to make your existing guaranteed messaging applications work with partition queues, you really don't have to do very much. Literally for your consumers, all they need to do is make sure they're using the latest API. That's it. And they will be able to bind to a partition queue, no problem. And for your publishers, same thing. They just need to use the most recent API, but there is just one line of code they have to add, and that is to add the partitioned key. And for that, we use actually a JMS property that is specifically for kind of specifying a group or partitioning. So our engineering team decided that this is actually the proper place to actually use this particular key, and that's what the broker looks for when you publish a message. So. All right, so I've built it. So this is all using Java. I use Gradle as my build tool here. Let me zoom in a few more clicks. So I got Gradle, assemble, and then just go to build staged. And yeah, this is ls bin. Here's all my different little apps that we're going to be running today. So now this is the terminal app portion of the demo. This is all my Java apps, but I also have a JavaScript kind of dashboard that I've built using JavaScript, kind of vanilla JavaScript, and D3. And I'm just going to pull it up here quickly. All right. And I'm just going to quickly switch the queue that we're looking at. Obviously, this is the partition queue. I should have probably set this up properly before, but this is actually using SEMP to query the broker and actually display the partitions and the consumers and publishers connecting to it in real time. So actually, you know what, we'll start with this. So I got my partition queue here. I'm going to now fire up a number of publishers and subscribers to connect to it. So just kind of like our picture had there. I need to log into, sorry everybody, because I'm doing this kind of manually, I now need to log into this thing a couple times to have my different apps. So I'm running this in AWS. I thought I'd rather not run it on my laptop just because of all the build staged, because of, well, quite a bit of horsepower to stream and to like do a lot of messaging. So PQ build staged, and last one. All right, so we'll start with 4 terminal windows here. Let's fire up a subscriber just so you can see what's going to happen. So when I fire up a subscriber, the dashboard here is going to be listening to these. The dashboard is actually listening to the broker event logs. I'm actually subscribed to the event logs coming out of the broker. And this way, you know, the dashboard here is going to be aware of clients binding, clients connecting, disconnecting, when the partition queue rebalances or partitions are assigned. All of these are evented in the broker's event log, which if you logged into the broker, you could actually go look at the log file. But you can actually subscribe to these over the bus as well. And so I thought that would make my demo kind of visual and kind of real time. So even if you don't have SEMP access, oh, by the way, Ed, you've heard about this CORS restriction that's now in the broker that maybe came out maybe last version or the version before? You have to allow any host. So because this is a JavaScript dashboard polling SEMP, by default, I can't actually connect to Solace brokers anymore because I get a CORS restriction. So I found that a bit annoying. Because I used to have a dashboard that worked back in the early days. So
yeah,
I had to figure that one out.
Security is it's never fun.
Yeah. Yes,
but
I just
important.
Unencrypted, unsecured is just much easier to work with, but obviously not in production and not for.
Yeah, we definitely need that as part of our session management. As soon as you store cookies, you can't just allow everyone in.
That's right. That's right. All right. So where is my? All right. This is what I want. I'm going to connect to this. So this is basically running off my subscriber. I don't know if you can read that here. My IP address, VPN, username, password, and the queue I'm going to connect to. So I'll just connect one subscriber right now, and you can see this in action. So there's my connection. He's bound. Now the first thing you're going to notice here is my queue goes into this rebalancing delay. So that's one of the two properties that you have when configuring a partition queue, right? So besides the number of partitions, there are two kind of additional settings. The rebalance basically is how long the queue waits between when it sees a first client either connect or disconnect and before it actually starts to reassign the partitions, right? And by default, that is 5, Ed, should be?
5.
And 5, which is quite short, So if you're adding, essentially, I think that kind of assumes you're adding one client at a time, and then you're going to let it sit for a while. That 5 seconds, essentially, it means if you want to connect multiple clients, at the same time, you would want them all to connect within that 5 seconds. Because if you get to the end of that 5 seconds, the broker says, all right, we're going to start assigning partitions now. And then 2 seconds later, you have another client connect. It's going to go through that rebalance. Well, we'll see. I'll fire up another one, right? It'll go through that same rebalancing again, right? PQ12. Again, he's going to connect. There we go. The dashboard sees it. Bind to that queue. I have my rebalance set to 10, by the way, so that's why we're seeing 10 seconds here. And there we go. We've assigned the partitions. I've not had any luck trying to figure out the best order to kind of display the partitions in. For 12, it seems to be kind of always an X, and for 3 partitions, it's the other way around. They're kind of connected in order. So the order, we the graphical users don't get to choose and validate the orders that we get. These partitions get assigned, but these clients don't actually know what partitions they connect to, right? As of today, client APIs are not aware. Like I said, they shouldn't really care. They just bind to the partition queue, and the broker will then assign them one or more flows. Well, I guess there could be less than one flow if you have more than 12 consumers, right? So,
yeah.
So they'll get assigned some number of flows, and then the broker will just start delivering the messages. So the clients don't actually know who they're connected to. I'm just visualizing this because I'm listening to the broker logs, which is not necessary, certainly not necessary for operations. It's kind of just interesting to look at, right? So because I wanted to emulate this slide. Nope, this slide. This is literally what I wanted to do, is build something that looked like this to make it real time.
Yeah.
How about we fire up a publisher?
Oh. Yeah, the clients receiving events will have the partition key in it. So if you do want to see that level of detail, it's there for you.
That's right. That's right. And that's because the partition key is part of the message, right? We add it as additional property to the message. And so that passes, all the way through. We don't transform that or do anything with it. Well, we assign the partition based on it, but we don't change that. So yeah, the subscribers can see the key, and we're going to see that as well in just a second when I fire up the publisher here. So again, another console app, PQ Publisher this time. Connect to my broker, and I'm going to publish on a topic. So all of my queues are listening on topics that look like their name, which is a little bit cheaty, but so he's going to start publishing here. There we go. We can see immediately some sequence numbers. So by default, I'm publishing on 8 keys, and that's what's after the dash here. And you can see that these consumers here are now getting, let's see if I can zoom in another click here. No, shift that over, zoom in, there we go. I don't know if you can read that, Ed, let me know.
Yeah, it's good.
Is that coming? Yeah, good. So take a look at the keys here. So we have keys 0, 5, 1. Here we have keys 4 and 7, 6, 3, right? There we can see that our kind of key sorting is happening. So obviously quite slow and quite low. But this is the advantage of the partition queue, is that the messages are going to be sorted by the keys that are being published there. We can actually take a look here and see. Well, we only have 8 partitions or 8 keys. So is there 8 keys only and 12 partitions? We're going to have some I don't know, some unused partitions, won't we? Is there a recommendation on how many keys we should have? Is it just kind of as many as possible? Is that what we tell customers?
In general, I'd say, yeah, it should be really as fine-grained. It should be as fine-grained as the data you're carrying requires it to be. So, you know, you're not going to create keys when it doesn't make sense for your application. But obviously, if you have fewer keys than the number of partitions, then some of those partitions are just never going to be used.
That's right. Yeah. And which essentially means that you might not get a nice even distribution of partitions. And that means if you need to scale up your number of consumers, some consumers could be binding to partitions that have literally 0 messages going through them. And adding consumers is not going to improve your messaging behavior.
Yeah.
As a brutal example, I mean, I could switch this to, one key, right? And let me crank up the message rates here a little bit. So by the way, this demo, the way that a lot of the kind of configuration for it works, the apps, all the publishers and the subscribers, everybody is listening to additional, it's not just using guaranteed messaging for the partition queue part in the middle. They're actually all subscribed to direct messaging topics as well. And I using a Solace topic hierarchy, a topic and a subscription that looks kind of like this: PQ demo / control / some combination of either all the publishers, all the subscribers, or individually for a particular client, and then a command. And here are the various commands. I wanted to make this demo. I love SDK perf. Ed, I've used SDK perf probably more than, well, QA use it quite a lot, right? But SDK perf I did a whole office hours on SDK perf with Mark a couple months ago, and it's a great utility. But if you want to change the message rate, or change the message size, or change the number of keys, you have to generally stop it, restart it with different command line parameters. And that's how I started out with this demo, is it was all command line parameters. And I'm like, I want some way of injecting state into these applications dynamically. So I thought, well, they're already connected to Solace. They're already wired together. Why not use some topics? So by publishing on topics, I can actually control the apps, right? So here's my one kind of horrible example. I have one key, publishing on one key, and I have, it's all, you can see that it's only going to one, exactly one partition. How would this work if this was a regular non-exclusive queue? What would be happening instead, Ed? We should see.
So half of them would go to sub 4 and half would go to sub 5. So
that's right. Yeah. So kind of having one key is a very degenerate case. That's essentially as if you have no key, right? I mean, it's actually, no, it's worse than having no key. The Solace broker behavior for partition queues, if you don't specify a key, is that default kind of non-exclusive queue behavior where it will assign a partition randomly or in a load balanced way. I'm not sure. I think randomly, right?
No, it should cycle through them. But,
okay.
Yeah.
Okay. Actually, so let's just quickly check that. So I don't want to sorry, I don't want to. I can't actually turn off keys on my app. That's one thing I can't do. Is you have to have some number of keys. You can't set it to 0. Maybe I should add that as a feature. But if we wanted to compare this to, well, we'll compare it to non-exclusive queues in a little bit. If I had a third subscriber come along here and connect, actually, let me change the rate. Should have had a list of things I wanted to show off here. Let's put it up to 16 keys. That might start to give us a nicer distribution. There we go. We can see that most of the partitions are being hit now. So what you're seeing here, these metrics, I'm actually using SEMP. The dashboard is pulling SEMP to the broker in a fairly aggressive fashion. Again, I wouldn't recommend this in production and is unnecessary, but I just wanted to make the demo live and kind of real time. But for those that know SEMP out there, yeah, I'm looking at the depths, the number of messages spooled on each of the partitions, as well as the rates. This is ingress and egress rates of each partition. And it, again, with a well-balanced, well-chosen kind of number of keys, these should all be fairly the same. We got a few. You can see down here, partition 6. Can I zoom in one click? That's all right. Partition 6 here, 0. Nobody is mapping to this thing. I guess there's no way to know, right? We don't say what the hash function is, so it's ideally.
Yeah,
you just have
we
a large
don't.
number
Yeah,
of
we don't say
keys.
what it is, and I don't think we have any plans to have it changed. But yeah, at the moment it's just basically a normal sort of cryptographic hash that happens.
Mm-hmm. And so you can see here on the console the kind of the data that's actually generating the actual apps that are generating this stuff. Here's my publisher publishing away. We talked about sequencing earlier, but I actually haven't turned it on yet. That's why you're seeing this kind of no OC happening on the left. They're not actually publishing any sequence numbers. That's the second number in this column. So we can't actually do any verification yet of the sequence number. Where's my, hold on, you gotta cut and paste here my thing. Sorry, Ed. Is that the right one? I hope so. Nope, that's my broker. So I'm running a broker in Solace Cloud. Let me just switch to my notes here. Sorry, not in Solace Cloud, in AWS. I'm running my own broker. Where's my SSH command? One moment. I love live demos. Makes you stressed out, trying to get it all kind of working nicely. Let me log in here. Okay, PQ demo, build staged. Let's run one more, PQ sub. And pass in that PQ12. So what we should see here, we're going to see another subscriber bind. Now, because I have actual data flowing through my partition queue, there's an additional timer that happens at the end of the rebalance delay. So there's going to be that. I have it configured for 10 seconds, where the queue waits to see if anybody's more is going to connect, if we're going to have more subscribers join. And at the end of that 10 seconds, there should be an additional delay called the handoff timer. And the handoff timer essentially says, all right, we have some new guys. We have to reassign some actual kind of live messages flowing through them partitions to someone else. And the broker is going to actually pause those partitions in preparation to flip them over to the new subscriber. So we should see when this guy joins, some of the partitions start to fill up just at the end of the rebalance during the max handoff timer. So let's check that out. So join my subscriber here. There it is. It's connected and bound to the queue, waiting for that flow active notification. And we should see a couple queues here switch into. All right, so they're a handoff timer. Oh, so these two at the top are buffering. This one as well. Whoop, it flips over, and we get a burst of messages into that new subscriber. There we go. So there is consumer scaling done, right?
Yeah.
So
should we talk about why we do that?
Yeah, sure. Yeah, that'd be that's probably good. People are like, okay, that's cool, but
yeah. So I mean, again, we want these consumers to be getting consistent and coherent order of these different key flows that are going through here. And when you hand obviously one partition off to another consumer, you have a risk of perhaps getting stuff processed out of order. in time.
Right.
So if there was a backend system with a database or something like that, we don't want one of these consumers to still be processing something of that same order or whatever at the same time as another one. And so what we're delaying for there is to allow all the messages that have been delivered and are in flight to that consumer to be acknowledged. And so we use that acknowledgement from the consumer to say they're done. They've already handled all of the stateful processing that they want to do, because you wouldn't acknowledge the message until you've finished that. And at that point, we know that those in-flight messages have been processed, so it's safe to move the partition somewhere else. And again, the setting of that timer is really up to the type of application you have, how long it typically takes to process things, give it a bit of buffer, of course, and it should be safe to allow these dynamic partition reassignments.
That's right. Essentially, when you have a new consumer join and we have to move some partitions, you don't just want to yank the rug out, essentially from, you just don't want to rip away someone's partition from them if they're in the middle of processing, right? You'd rather do it in a bit more of a graceful, controlled way. Let me just go into my queues here. Whoops, queues. So this is the broker I have running in the cloud, and I got a number of queues that we're going to use for this demo. This one's the one we're connected to right now, PQ12. And under settings, you can see here's my partition count. I have 12 partitions. And if I click on this show advanced settings, then you can see these two associated timers that at delay by default 5, so quite short. I could see that in production you wanting actually maybe like 30 seconds or something, because if you have maybe a temporary network glitch and maybe your client bounces for 10 seconds, maybe you'd want it to come back to the same place. You wouldn't want the queue to rebalance in the middle of that. I could see cases where I guess it's a trade-off between how reactive or responsive do you want your partition queue to be to changing consumers versus how stable. If you have some kind of flap, you don't want it to bounce around too much, right?
Yeah,
There's probably
exactly.
some discussion. I don't know if we have guidance on that, but
well, again, with that rebalance handoff time, there's you're getting these pauses or whatever when that happens. So you don't want, like you say, if a consumer goes away for a short period of time, you don't want everyone to get rejigged, only to have it come back, and then you have to do that again. And so you will, like, during the rebalance delay, if the consumer comes back and it hasn't crashed or whatever, there's a bit of state there. If it comes back, it always gets the same partitions within that time, and it just all carries on.
I can actually demo that. So you want to see this? So, these little emojis that I have here, these are actually actions I can do. So the little angel guy is a graceful quit. So like you die gracefully. The skull is instant kill, and when I get that message, I actually do a system.halt in Java, which essentially just tears it down right away. And this basketball is my bounce a connection, so I can bounce the connection. And actually, the dashboard is publishing a admin client disconnect semp command, and so we can actually do that. Let's bounce this connection. He should reconnect right away and should get reassigned right away these partitions. Boom. Yeah, there you go. It happened so fast, it was hard to see, but you do get a couple redeliveries. Let me do it again here. Bounce. Like that's how fast it reconnects, So our APIs automatically do that reconnection for you. I don't actually have to code anything in that regard. But if they do come back right away, then yeah, the broker just reassigns them those partitions and everything kind of carries on as normal. Plus maybe some redeliveries if there was some outstanding messages. So, but yeah, on this max handoff timer. So this is essentially if your apps are processing their messages very quickly and then flushing them to the back end very quickly, and then acknowledging back to the queue very quickly, this could probably be fairly low, right? That's essentially what we want to make stay is like this max handoff is how long the broker will give a partition to finish, or a client to finish acknowledging and processing the messages that it has before it takes it away. So this is where, based on your application behavior, this is where you might need to adjust this. If you have an app that might hold on to messages for, say, 30 seconds, right, Ed? Just like to make an extreme example. Yeah. I don't know if that's correct. 30 seconds seems quite long. Before it actually flushes it to the back end, maybe some big batch database write or some kind of big blobby process, you would want to make sure that this is at least 30 seconds, right? I mean, that's how I would see it.
Yes. Well, you'd want to give it a bit of buffer as well on top of that.
Plus, yeah.
But again, this is the maximum time. So this is where we'll give up on you. We'll say, all right, well, we can't hold off forever. Let's just go because it seems like that application stalled or is not working anymore.
That's right. That's right. So at some point, we're going to flip it over. And even if you have unacknowledged messages, those messages, because, this is Solace guaranteed messaging with, queues and acts, any messages that are not acknowledged that have been sent to that previous consumer, maybe because they're slow or maybe because they've delayed for too long or something, those messages will get redelivered to somebody else. Part of the reason why I wrote this demo was to kind of demonstrate a lot of these features and functionalities. So I can actually add a sleep in the processing thread of these subscribers. I can slow them down. I can add a delay to how long they take to acknowledge their message. So we could easily change this delay to like 30 seconds, and we could see that in action where a client will actually delay. Messages that have not been acknowledged will actually get sent to another consumer. But in order for that to actually happen, I need to turn on sequencing. So that's the other part of this demo. I built in the ability to wrong screen. On each message that I publish, I'm actually using both a partition key and a sequence number to actually kind of to verify. Essentially, your application may or may not need sequence numbers. I just wanted to build them in as a way to prove that, we're not seeing any gaps, that all keys related to the same subscriber are going, or on the same key are going to the same subscriber, and it's checking for gaps. So both the subscribers are looking for gaps in their data. And then I actually have a third kind of listener component. I'm going to go ahead and fire it up right now. I have simulating essentially the back end, right? So pretend it's a database, pretend it's a file, pretend it's another Solace queue maybe. And this is my order checker application. And it essentially is listening to all of the data coming out of these subscribers. And what that means is the subscribers, when they act their message, when they actually finish their quote unquote processing, I have too many screens here. So when they finish their quote unquote processing, they'll actually, when they act their message back to Solace, they're going to publish a little confirm message, a processed message that this order checker is listening on. So this is verifying that other part of the kind of requirements that we had, that the back end sees the kind of like the total order is guaranteed, right? And even if you flip partitions around, or even if you kill a consumer, the back end is still going to see things in the right order. We might get dupes, obviously, right, Ed? I mean, there's no way to get around that. If you kill an app that hasn't acknowledged its messages, you're going to redeliver those messages. But part of the benefit, and not beauty, I mean that's a bit strong, but part of the advantages of having these kind of max handoff timers is that you should not get duplications in kind of normal situations, because the partitions should pause, and we're going to see that in a second, and allowing that when that partition gets flipped over to the new consumer, that messages have all been finished acknowledging, and the new ones that are on the queue are all fresh, and they'll start going to the new subscriber. So here's my order checker. You can see it's receiving a full. Every time one of these guys receives a message, it'll publish a message to this guy. So his rates should be more or less the same. Obviously, we're having a kind of a load balancing here across our consumers. I'm going to turn on ordering now. So this will add the kind of sequence verification to my app, so that all the sequence numbers are still 0. So let's turn that on. And the way that I do that, it was the way that I first coded it, and I actually still haven't changed it. I have this probability amount between 0 and 1. If it's 0, sequencing is turned off. If it's anything bigger than 0, it's turned on. And essentially that means the probability that I'm going to publish another message with this key later on. If I only have 16 keys right now, so obviously every key is going to get published on repeatedly, right? But if I had a trillion billion keys, randomly choosing the same key to publish on again is not going to happen, right? Your likelihood of publishing on the same key again. So I made this, essentially I have a little queue, the publisher has a queue where messages, if they're going to be republished or resent with the name, with the same key, they'll get stuck into there. So let's do this 0.5. So there's a 50% chance every message I send will be sent again a little bit later. All right, so everything's still the same, everything still looks the same. Order checker here, you can see now it's listening for the total number of keys that it has seen so far. And on the console, this is what we're seeing. Let me zoom this out a little bit. There we go. So basically the subscribers, if they receive, so every key that they're receiving, they're keeping track of the sequence number on that particular key. So here are my, I have 16 keys. So each one of them is getting about 4, 5, 6 keys, and they're actually tracking the sequence number message by message that they're receiving. And you can see that the subscribers all green, right? Each key, because we're doing that partitioning, is all green. And the backend order checker, it is seeing the result across all of the subscribers. So it is seeing it's saying everything is happy. Just to show you that, to prove that this works, how about we run this for a non-exclusive queue, Ed? And then that should really show some ordering problems, right? Let me quit these guys. All right, so I'm just going to send a control message that they're all listening to quit. There we go. Queue finished draining. All the apps hung up nicely. Excellent. So I have a non-X queue. So this is going to restart. There are some very basic instructions, like if you just load this demo without any URL, all the URL parameters are kind of up here at the top, and that's actually how I kind of connect to, where the broker is. This will probably be a nice little dashboard that you fill in at some point, but right now it's just you pass them as URL parameters. So it kind of explains how to run the demo. So I'm just going to literally use the exact same apps, and all I'm going to do is just change the queue name that I connect to, non-X. So broker, VPN, username, password, queue name. So here we go. I now have 3 subscribers bound to my queue. It knows that it's a non-exclusive queue. It's checked using SEMP. It can see that the partition count is 0, which means normal old partition queue, right? And it is I'm going to start up my publisher here. Again, change his topic that he's publishing on. I have a topic called non-X that my queue is listing on. You might wonder if you caught that why I'm putting a slash at the end of my topic. Solace doesn't really allow topics with empty levels in JCSMP. I'm actually using it as a topic prefix. And so whenever I publish a message, it's actually building a message with the publisher name, the key number, the sequence number, all kind of part of the topic. So that's just to make it if you're listening using, the Try Me tab or the Try Me app or SDK perf to kind of see the messages flowing through. That's just an explanation of why that's happening. So there we go. We got our, by default, 2 messages a second. Let's crank it up to 10 messages a second. We should get a nice round robin. Well, we have 3 consumers. So let's do 12. Let's do 12 messages a second. So this is our traditional non-exclusive queue. It round robins without even if you have a key, it doesn't care about the key, right? So it should just go around between them. 4 messages a second each. Sounds good. Let's turn on some order checking. How about that? So there's my order checker turned on. And now I will enable some order checking. So probability, let's do 0.5 again. Send. All right, so I hope you can see this. We have some subscribers complaining about gaps and changes in their sequence. And if I look on the console, look at that. There we go. Oh, my light just died. That's good. I charged it up this morning too. All right, what can you see there, Ed?
Yeah,
doesn't look great, right?
On the consumers, of course, the order checker, I guess, is just going fast enough that they still show up in order for that one.
Exactly, that's exactly it. So the subscribers on an individual subscriber level, on a per key basis, they're seeing gaps, right? Because the broker is just round robining among any of them, right? So the broker doesn't care about keys. So it's just sending whatever keys to whoever. And so on average, especially the more subscribers you have, the probably worse it gets. But the chance of you getting the same related key back to you a second time is not going to happen. So this is just to prove that I do have actual validating sequence code in these subscribers. And yeah, you're right, Ed. The order checker is still seeing all green, all tick marks, and that's because, to your point, it's going fast enough. The message rates are low enough, and the subscribers are just acknowledging and processing their messages very quickly. And so it's just passing through to the backend order checker in the correct order. We don't have any problems there. So in those cases, if your message rates are low enough, maybe you don't need to worry about partition queues. Or how about this? Maybe if you're guaranteed that a related message, so like your cancel order is not going to show up for at least another 5 minutes, by then you would have flushed that order to the back end, then maybe partition queues, you wouldn't need to worry about it. So I'm sure there are some weird messaging situations where maybe you don't need a partition queue, but it just makes it so much easier.
I would say in practice, pretty much every time you make that argument, will fail on you eventually.
Yeah, that's right. Yeah, exactly. There's always something will go wrong somewhere, right? And you'll get a cancel message very quickly after your new message, and it goes to the wrong consumer, and that consumer says, "What the heck is this? I'm going to fail," and then the thing gets purchased anyway because the purchase order went somewhere else. So, all right, so let's make some gaps. How can we make gaps? We could add some delays. We could increase the message rates. I don't want to increase the message rates too much because I like kind of being able to see things scrolling by here. But let's change one of the subscribers to add a delay, right? So let's make one of the subscribers hold on to their messages for a little bit longer, and we should see that kind of get impacted. So I'm going to let's choose this bottom guy, A6CC, sub A6CC. I'm going to change your ACK delay. Let's make it a second. So this guy's going to hold on to messages for 1 second before it acknowledges them. And almost immediately, look what starts happening. Order checker also starts seeing gaps and changes in sequence and flashing. I really want to make it visually obvious, when things are going wrong. If the order checker sees gaps, that's a problem, right? Maybe if your subscribers are seeing gaps, that's not as big a problem, but if the order checker is seeing gaps, that is not good. And you can see here on the console it complaining. Let me scroll this over a click, and I can zoom in a little bit. So there's my order checker. So you can see that it's actually tracking which messages it's missing on a per key basis. It's actually saying, oh, I missed this number, I missed this number. But if you paused it, I don't want to get too much into the details, but the messages do eventually, those gaps disappear, right? Essentially the messages will come, you'll see that some of the sequencing there is saying jump, rewind. So we're actually, the gaps are being filled in because it's just being delayed, but the overall order is now broken. So here we go. Very much proving that non-exclusive queues can't be used or trusted for, for sequencing, right? So there we go. Yep. Quite a lot of error logs. Obviously, if I turn down the message rates to like super, super low, message rate, missed that. Message rate, 1 message a second. Obviously, at 1 message a second, again, if the rates are low enough, these guys will still be complaining about gaps, but this guy he still has a gap. Oh, look at that.
Okay. 1.2 or something. You're right on the boundary.
Well, it's a bit of a race condition. Yeah, I guess, yeah. A little bit. So he's still going to see a few gaps. These guys are obviously still going to have, that's not going to change. The message rate's not going to affect whether they see gaps, but whether the backend sees a gap. So you can see, so in my sequence code, I have this jump, rewind, okay. Okay means it's the next message in the sequence. So lots of, fairly complicated sequencing code. It took me a while to kind of write it and kind of figure out, what's a warn and what's an error, what's a debug, trying to make it correct so that, you don't get alarmed unnecessarily. Sometimes, when you get a duplicate, that's completely normal. When a subscriber gets a duplicate, the broker will set what's called a redelivered flag. and actually the demo watches for those as well. So when you get a failover, often, yeah, clients' applications can get a redelivered flag, just to the broker trying to tell you, hey, I've already sent this message to somebody else, but never got an acknowledgement. Which are, I think the only time you can't really fully trust a redelivered flag is in a DR scenario, right, Ed? Like if you have a full-on DR incident, it doesn't know if a message has been attempted to be delivered. So there are some, there we go. See, look, it settled down. Oh, no, there's a jump. Okay. It's also, I wanted to call out, you know, the order checker checks which subscriber is sending a particular key. So it's not an error, like these are all at info, but you can see that it's noting that where subscriber is changing. So again, with a partition queue, we're not going to have this just because, except unless we're doing up changing the number of consumers. So let's go ahead and switch back to a good old partition queue and do some more testing. I wonder if we have any questions out there. Any questions? Oh, someone wants a job. All right. Can you tell me, do you offer courses? Yeah, actually, we have Solace has an LMS that you can sign up for, our learning management system. I think you head over to, I think it's training.solace.com. Yes. I think. Yeah, thanks, Ed. So yeah, and obviously I got a ton of videos on YouTube. A lot of my colleagues have a lot of videos on YouTube. If you just search for solace.com on YouTube, you should find quite a lot of our videos. They're often more around kind of integrations or new features rather than kind of like actually dedicated training course. So yeah, check that out. Sissy, thanks for posting that link. Yes, SDK Perf in action. I actually ended up talking for about an hour and 15 minutes about SDK Perf, and I still had more kind of things to cover. So there's a lot to it. If you're a Solace user and you don't know how to use SDK Perf, I highly suggest you check it out. It's a command line tool, and it is super helpful for lots of jobs. All right, this is cool. Excellent, thanks. I hope people like it. All right, let me kill these. So so non-exclusive queue is not gonna work. This will, if we connected all these to an exclusive queue, actually let's do that really quickly, just because I wanted to make sure this demo is going to work for everything. So if people had to guess what a exclusive queue is going to do, should be, well, I hope pretty, let's do three connections to an exclusive queue. There we go. Fire up my publisher or my order checker again, and the publisher. No, I have to end with a slash. All right. So what do you think, Ed? It looks kind of the same, doesn't it? But a few less lines. So the reason for that is with an exclusive queue, only one, essentially the first one to join gets an active flow notification. So here we have essentially one active consumer, right? What's going to happen if, let me just turn up the rates here a little bit so we can see something interesting. Crank up the message rates, 10 messages a second. Oh, let's turn on our sequencing as well. So again, I have to do this prob, send a prob message that's non-zero. Whoops, that's a typo. For those of you thinking it's really annoying that I have to kind of resend these control messages every time I load it up, I do have a little trick for that, and I'll show you what that is in a second. So here we go. We're doing 100 messages a second. Sequencing is enabled. I only have 8 keys. Let's increase that. Let's do 256 keys. Doesn't really change very much. We should see, yeah, there we go. So he's set to 256 keys. The order checker is seeing a lot of those new keys now. But yeah, because we only have one consumer, obviously that one consumer is getting everything, right? So there's actually zero chance for any out of orders. It's getting everything. So we're not doing any round robining. We're not doing any parallel processing. On the console, you can see that only one app is actually scrolling by, right? These other guys, they've connected. Yep, there's my typo. They see the apps are actually doing some error checking. So good coding there. But yeah, what happens if we decide to disconnect one of these guys? What should happen, Ed? Tell the people.
It should move to one of the other two. They're on standby.
It should. So they are sorted kind of top to bottom in terms of when they connected. That's the way the dashboard kind of like just adds them on. So if I kill this guy, do a graceful shutdown, there we go. It flips over. and the second guy takes over and might have to catch up a little bit on those messages, and that's it. And that the disconnected guy will kind of go away. And what you noticed, order checker did not see any gaps, like it didn't flash any colors. Even this guy. So that's kind of something interesting that I found out through working on this demo was with old school regular exclusive queue flows, the API will actually help dedupe some of the redeliveries to a client. No, actually that wouldn't apply here because we did a disconnect and a failover. But if you had your connection bounce, if you kept your state, then you won't get any fail thing. So if I bounced my connection here like we did before, whoop, oh right, because I have 2 subscribers. If I bounce my connection, the next guy gets activity. So yeah, there we go. We get a quick failover. So I can fail back and forth between these 2 guys by just bouncing the connection. Oh, that didn't work. Bounce. There we go. Boom.
Yeah. Well, one thing I'll just point out here.
Oh, I got some gaps because I screwed up my code. I knew my demo. I knew something was going to break at some point today.
But since you're showing off this behavior of 2 or more of these connected clients, even without messages, we use this technology of having only one active consumer for doing semaphores and mutual exclusion between different applications. So you can actually just, even without messages, use up a queue to bind a number of different applications, and only one will win. And if one of them goes away, one of the other ones will be told that they're now active. And there's a lot of good things you can do from a redundancy point of view, or other types of application behavior where you need to know that, and it just saves you having to have communication pass between multiple parallel applications.
That's right. So I know that in the field, SEs, PSG people, we've been promoting the use of an exclusive queue, like right here, kind of as like a network mutex essentially, or a lock. And to demonstrate that, I have 0 messages. A typical use case for this is determining who's the active publisher. Like if you are building an app where you want to have high availability, so you want to run 2 versions, like a hot standby, and they're both publishing, you want to know which one is supposed to be the publisher, they could use a queue. Not to receive any messages from, but just literally this kind of signaling. So I can, when one disconnects, if I bounce that connection, bloop, this other guy will get the flow active. So you can see the different, these are the flow active notifications. And if I bounced him, bloop, it goes back to the other guy. So yeah, just knowing whoever receives that flow active notification, right there, flow inactive, blah, 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 flow up. So not flow up. Flow up means you've connected to the queue, but flow active means you're actually the guy, right? So yeah, you can play with this demo with exclusive queues, non-exclusive queues, partition queues. I mean, I made it for partition queues, so that's the main thing. Let's go back to our PQ12 here. Let's go back to our lots of consumers. I forgot to quit everybody. All right, so Control C does a graceful shutdown. So it listens to that kind of command, I guess you could say, or hook. Interrupt, you'd say an interrupt. Most of my demo, my code listened to the enter key, and if you press Control C, it would just terminate immediately. But in Kubernetes, well, one thing I want to basically, my next video I'm going to do, our colleague Dennis from the CTO team wrote a plugin for Kubernetes, the KEDA. So this is called the Kubernetes Auto-Driven Event. Kubernetes Event-Driven Autoscaler, right? Yeah. And this is a kind of part of Kubernetes, part of CNCF, that allows you to have multiple partitions, or sorry, multiple apps that scale up and scale down. In Solace world, this would be Solace consumers on a partition queue, on a non-exclusive queue. But if these consumers are running inside Kubernetes, you can have this KEDA application or utility, I don't know what do you call it, I guess it's a utility, watching the rates of this queue and the depths on this queue, and it will add and remove consumers dynamically. And so I'm going to be doing a video, probably I might actually end up doing an office hours on that with Dennis. But if you're running Solace apps in Kubernetes, there is something out there to actually help you with this scaling, how to choose when you should add more consumers, right? We built this partition queue feature. We have it that you can scale the number of consumers up and down, but you typically wouldn't have a person sitting there watching, right, Ed? You wouldn't have some operator sitting there saying, add one more, add one more. You'd have some automated tooling.
Yeah, absolutely. Either something that's watching the consumers themselves or watching the queue depths to see, or both.
It could be either, right? I mean, it could be, I would say it'd be safest to watch both. Just like in my demo app, the consumers, the way that my dashboard knows the message rates on the consumers and some of their stats is the consumers are actually publishing kind of heartbeat messages. Once a second, it's publishing a stat message with its current message rate, if there's any gaps, all that kind of stuff. And the KEDA process, I believe, just watches the queue. But if you wanted to, we could enhance it. It's all open source. We could basically add the ability to kind of monitor consumers as well. If you had a consumer that was misbehaving, maybe you could chop it off, right? Rather than trying to add new consumers to help a slow subscriber that's actually a dying subscriber, for example.
Yeah.
I don't know.
Yeah, and I think that one's a little bit more application specific. That it's hard to, in general, just watch consumers and know that should we be looking at CPU usage or whatever, right?
That's right. There's a lot of metrics. Yeah.
Yeah.
I mean, like for one application, consumers could be very bursty and then very slow, and that's completely normal. Or they could pause for a really long time. That could be completely normal. Maybe your queue is allowed to fill up quite a lot, and that's completely normal. Like there's a lot of, you have to, when to scale your apps, when to add or remove these consumers on the partition, that's really dependent on your setup, on your use case, on your application. So it's very hard to be generic. So there is some per application, kind of configuration that you need to do as part of this, as this kind of setup, right? So, all right, let's go. My partition queue is back up. Here we go. Let's fire up some more subscribers. I'm gonna get one more window here. I want to do a 4 subscriber. Just get this really, really cranking along here. Come on, I thought I had all my commands here all built in. Yes, PQ demo, build stage. Okay. And as I said before, those control topics. So as part of that, part of running in Kubernetes, Dennis, my colleague, made the point where, well, if you have another subscriber join, you want to make sure that they inherit all of the properties that maybe you have added in terms of these control messages. Or you have another publisher join, you want it to be doing the same thing, right? If it's a slow subscriber simulation, when that subscriber joins, you want it to start slow. You wouldn't have to want to inject that control message right away. So I have a little app that I call my stateful control, and it actually does that. It manages the state that it sees on these control messages, and then when new applications join, they do request reply. So yeah, this demo uses like all the different kind of flavors of Solace messaging. We do guaranteed messaging, we do direct messaging, I do request reply messaging with this control app, and all of it. And basically, the control app kind of helps when a new subscriber joins or a new publisher joins, that it knows the state of everything. So kick that off. It doesn't really do anything other than kind of just sit there and listen and kind of answer people or answer new. Oh, wrong one. Bin stateful. There we go. So it's going to start up. I still need to connect to my broker here for my order checker. So I'm hoping that people kind of like, I don't know, I've spent so much time working on this demo and just playing around with it. It's a great way to just learn about how Solace, the broker works, the queues work, kind of watching messaging kind of flip around back and forth.
Yeah, it's actually really useful. There will be a useful thing for even the designers to play around with when they're trying to debug something that's more visual, if you know what I mean. Like sometimes you're just looking at numbers on a screen and you don't see the behaviors that a visual display could show you.
Yeah, I mean, you and I both like to write demos. Making it visual just makes it much more engaging. but it's also being able to see things. Humans' eyes are great at seeing patterns that are visual that maybe we don't see with just looking at a spreadsheet of numbers or looking at a log dump, for example, right? And I don't know if anybody else has ever written something where they're polling, SEMP and listening to the event log at such kind of like frequency to have this almost real-time view of what's going on inside the broker. I don't think QA team's ever done that before. Probably hitting refresh on the Solace manager maybe, but yeah, I'm hoping that this comes in handy for QA people, for people to learn, people kind of like looking at their data. One thing I'll mention is while all this stuff is being logged to the console, there is also every single message is being written to a log file, and so in order, right? So even if you're doing 1,000 messages a second or 5,000 messages a second, every message is written in order in one of these logs, and you can, using your key, if you get a gap or you get something weird happen, you want to like, oh, okay, when did he actually send this, and da 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 da. You can go back to look at your publisher that you were using. When did it? What's the timestamp on it? The timestamp should all line up, but all of the per message logs are all actually here on the disk as well, which has also come in handy, kind of when trying to trace down when did you send this? I received it here. When did I ACK it? When did the order checker see it? All that kind of stuff, right? So. Yeah, hopefully useful for people. So I got my order checker and my stateful consumer or my stateful app running. Let's go ahead and just fire up these guys one more time. Bind to good old PQ12. Start up a publisher here. No, wrong topic. PQ12, please. There we go. There's my terminal apps. You can, of course, run this with just your terminal apps if you want, but that's kind of boring. Having the visual tool is the cool thing. By the way, this dashboard works for any queue. You don't have to use my app. You don't have to use, obviously, to have all the kind of the rates kind of getting broadcast. These you have to use my demo, my partition queue demo. But if you just had a queue on a broker and you had SDK perf connected to it, you would actually see those partitions, like who's mapped to what, because again, the dashboard is just listening to the event log to know which partitions are assigned. Oh, we have a question. Let's see here. Mohammed, in high throughput scenarios, is the desired end situation the consumer provides a way to scale up the computational complexity, or algorithm will be in the consumer clients? It could be either. It could be through consumer scaling, just in terms of number of consumers that have bound to your partition queue, or they could actually change internal logic in order for them to help process messages faster. I've seen both, and I've seen both used together. For example, I think my colleague Tom recently came up with one. So basically, there's a banking customer, and they had basically some kind of big, complicated risk management calculation that they're performing. And when the market rates are low and the kind of data plugging into this thing is not going very fast, they can do the kind of really complicated algorithm, which is very accurate. But then if message rates are very high and you want to be able to make sure that you don't fall behind, the app could then switch into kind of a best guess or a kind of a rougher estimate in order to kind of speed up faster. So that would be my answer for that. In high throughput, you could either just scale up the number of consumers. Obviously, I have 12 partitions here. I should be able to scale up to 12 consumers, and if I have nicely balanced keys, then they're each getting ideally about 1/12, right? Again, it comes down to your choice of keys. But if once you hit there's no way to scale beyond that, I guess, is there, Ed, without doing actual partition scaling, right?
Yeah. Then you have to have more partitions.
Yeah, if you hit 12 partitions and you have 12 consumers connected and they're all maxed out and your queues are backing up, then you're going to have to you'll have to add some more. You'll have to add some more partitions.
Yeah,
so
there's certainly ways to do that. It's a little bit more disruptive, of course, to play around with the number of partitions.
Yeah. Okay, I'm just gonna fire this up. Now, I've been using this kind of little dashboard commands here, but you could also just, you could send these control messages in using the try me tab, the SDK perf. You could publish it as a REST message. Solace supports REST messaging. And so, oh, did that work? There we go. So yeah, you could inject it using curl, but you can also just use it with this stateful control app. So I got my 8 keys. I'm gonna turn on publishing here. Here's my little stateful control guy. So let's change keys to 256. I'm gonna change keys. Come on, Aaron. 256. Let's change my probability to 0.5 so we're publishing on the same message. Order checking is enabled. You can see all the sequence numbers there flying by. Let's add some slow subscribers. Let's show what happens maybe if like somebody slows down. So they're all getting they should be getting about 33 messages a second, right? That'd be about ideal. Split 3 ways. So what kind of delay do I need? 33. 1,000 divided by 33. Help me out, Ed. What's the
30?
Let's try that. So I'm going to add a slow subscriber delay of 30 milliseconds. Now this isn't exactly 30 milliseconds. I'm using a Poisson distribution to kind of slightly randomize how much you delay each message. So it could be 25, it could be 35 or 40, but it'll be on average the mean will be 30. So I'm going to add this. We should see these guys possibly slow down a little bit. They might not be able to keep up with the message rate, and we might see these queues start to fill up. Actually, just to make it more obvious, I'm going to just crank up the rate temporarily. Let's say we get a burst in messaging. All right, so now we're at 150. You can see what happens. Because we're actually pulling the dashboard is pulling the broker and pulling these queue stats directly, you can see that these, I got some shading here indicating the queue depth. The queues are actually, the partitions are starting to fill up. And you can see I've actually color-coded the ingress and egress rates. So you'll see kind of little bursts when they're like, all right, I'm going to pull the next blob of messages off. That's because the subscribers are kind of reading things. Well, they're acknowledging things in chunks, right, Ed? They're actually reading the messages one at a time, but they're kind of doing blobby acknowledges back to the broker.
Yeah.
So that's why we see some of these blobby ingress and egress rates there. So you can see that my order checker is getting about 100 messages a second. This guy is doing 150. Let's add one more subscriber. So we're going to see this in action. Consumer scaling, bin/PQ sub, and then the right. Oh, I don't have order checking turned on. Let me turn. Oh, I thought it was turned on. It is turned on. Yeah, you're not echoing every message. If the message rates are high enough, they basically stop echoing every single message to the console because it gets a little bit too busy. But it is still doing the order checking there. And we're connecting to PQ12. So now we should see that rebalance and then max handoff timers one more time here. So there's the rebalance at the end of the 10 seconds. Wow, some of these queues are these partitions are getting quite full. Whoa. Oh, it just reassigned them right away. Probably because we have slow subscribers. Maybe those messages were not, those partitions were kind of paused. So that's part of this max handoff is it will actually send things over once all of the messages have been acknowledged, right? So it doesn't necessarily need to wait the full length of the max handoff.
I mean, that's the max
time.
part of it's the maximum
yeah,
it will wait.
Max of the max, yeah, exactly. It doesn't necessarily need to wait for exactly that long. So yeah, your partitions could flip over anywhere between the end of the rebalance to the end of the max handoff, anywhere in that kind of range, right? All right, so I've turned my publisher down a little bit. We've got 4 subscribers now here. They should start to drain out. We have some more comments. My friend Running Roach, welcome back. Thanks for joining. Good evening. I hope it's kind of late at night. How disruptive would it be if 12 subscribers lagging on 12 partition queues with 8 messages per second? How disruptive would it be if 12 subscribers lagging on 12 partition queues with 8 messages per second, or taking a few seconds or in a few minutes? So if we have 12 subscribers on 12 partitions, if we added 4 more subscribers. So obviously adding 4 more subscribers to a 12 partition queue, if you already have 12 partitions, nothing's going to change. right, Ed? We would need
Yep.
to, yeah, we would need to change the number of partitions. Well, tell you what. So the biggest thing, to note that when you change, even if you're not changing the number of partitions, but if you're changing subscribers, if subscribers are coming and going, the keys, which partition gets mapped to which subscriber could change, right? If this number 4 guy connects and we get these top 3, and then he disconnects, it's not necessarily going it's not going to go back to exactly the way it was, right? Some of those partitions could get moved to a different client, for example. And so what that means is sometimes clients will suddenly start receiving keys that it hadn't seen before. And so that is probably one of the, and when you do partition scaling, if we added another partition, that is definitely going to happen, because the broker, the hashing, is now going to get spread among a new number of partitions. Think of it as essentially a modulo. I know it's more complicated than that, but essentially that's what's happening, right? We have a big order number, we're taking modulo number of partitions, and we're sticking it in some queue. So when you change the number of partitions, the key to partition mapping actually changes. And so consumers that, even if they were on the same number, they haven't moved, they're suddenly going to start getting new keys that they hadn't had before. And so that will be kind of the more disruptive part. In terms of how long does it take me to add another subscription or another partition and have the subscribers react to it in real time, like no time at all. I can actually show you that. Tell you what, I'm not even going to shut down the queue or do anything. I'm just going to add more partitions, and you can see what happens. Let me turn off some of the slow, make them a bit less slow. Let's put them to 20 seconds. I don't know. You'll notice that not all of them are going to switch right away because this guy is backed up. I'm sending a direct message. It's sitting basically backed up on this guy's. There we go. Now he got it. On his message flow, might take a few seconds for that message to go through. All right, I'm going to, on my other screen here, log in. I'm going to move this out of the way so that you can watch the queue as I do this. But I am literally just going to change the number of partitions on this queue, and you can see it kind of live what happens. The broker essentially adds the new flows to the subscribers, and the subscribers pretty much immediately start getting their new keys. If we watched on the console, you'd actually be able to see the, let's go up to 16. You'll actually be able to see these guys complaining about stuff. So here's my 12 partition queue. I am going to now zoom out a little bit. I'm going to make it go to 16. Ready? Watch what happens. Boom. That's it. There is going to be gaps and delays just simply because we have now switched partitions are going to which guys. If I had paused the publisher and allowed these guys to completely finish draining their messages, Ed, what do you think would happen? Should be no problems, right?
Yeah.
That's right, exactly. So it comes down to, in terms of like how long does it take to add partitions or to add new consumers to partitions, like instantly. I could do the exact same thing in reverse. Here, I know you can't see it, but I'm going to edit this. I'm going to put it back to 12. Same thing's going to happen. We're going to see, actually, look at this. We have a nice GUI prompt. When lowering the number of partitions, it is say messages could be lost. Why could messages be lost, Ed, but not going when partitions are added? Let's see. I'm sure you know this.
You're putting me on the spot here. I would imagine it's because some of those partitions are just being removed and you're deleting the messages that are on those partitions. If you follow the guidelines, the proper procedure, that wouldn't happen because you'd make sure that there aren't messages in those partitions.
That's right. Proper procedure says pause your publishers, stop your publishers, knack your publishers. Now all my queues are drained. Everything has been flushed. Everything is flushed to the back end. Your apps should be coded to, not to hold on to things forever, because if they hold on to things forever, when a partition gets reassigned, even without partition scaling, but just normal consumer scaling, suddenly that key is now going to be going to somebody else. And that somebody else is going to have to go to some back-end system and say, hey, I've got sequence number 5 for this particular key, and this is the first I've heard about it. Give me the current state, right? There has to be somewhere. Partition queues help reduce how often an app has to go to that back end, but you're still going to need some back end to say what is the, because when you flip over, we might have actually seen a few here. Let me just scroll up. You should see some firsts. Yeah, so here's some firsts and some gaps. I'm gonna have to check that. That's because I did partition scaling without pausing, because I was being silly. But yeah, so here you can see that actually on the console, the apps are noticing that they were expecting number 1 for this particular key, and instead they got number 214. And so it's like, it's not an error, it's just noting that has actually happened, right?
Yeah.
But if I had paused,
I was going to say to note that you don't have to necessarily go to all your publishers and pause them. You can shut down the ingress of a queue, and then it will just basically push back on all the publishers. So you might have a whole bunch of publishers spread around. Try to coordinate the pausing if that is a tricky thing.
Yes, I will make one thing to note on that is if you are publishing to a topic rather than publishing to a queue. If you're publishing directly to the queue, which is a bit of an anti-pattern, but definitely old school JMS, that's quite, we have a lot of point-to-point style, as we've been promoting this whole event-driven architecture thing, we've always been promoting publish on topics, well-defined topics, and queues will subscribe to those topics. By default, if you shut down your ingress, those messages will not be nacked, actually. There is an additional setting that you need to set on your queue, and I actually ran into this last night when I was using a new broker with a new queue. Under congestion control, by default, it is set to notify sender. This means that if your queue is full, because it's run out of spool or something like that, the publisher will get a nack. But if you shut down the queue, shut down the ingress, the broker will pretend that, oh, I don't actually want this message. I'm going to silently ignore this message. I'm going to skip this. You have to switch this to notify sender, including shutdown. This is quite important when you want to do your scaling. If you want to shut down the ingress of the queue to get knacks, the publisher should start getting knacks. That will happen. So things to note when doing your partition scaling there. Okay, I'm going to hit apply. That should switch us back to 12. There we go. There was another comment actually here. Running roach, right. I'm not reading I'm just reading these live, so let's see what happens. So let's say partition 1 and 3 are the ones that are getting overwhelmed. What we would want to do is split those partitions into 2 and then further pause to handle the subscribe. Okay. So the administrator and the apps themselves have no control over which partitions get assigned to what. We give you some guarantees that at most all the consumers will have the exact same number of partitions plus or minus 1. That is the metric, I guess. I don't know. But yeah, if you have one very badly behaving client, you might have to add quite a few subscribers. There's no way to say this one guy is bad, give me at least one of his partitions. Not today. There might be future work done where a consumer could request a partition, or we could kind of be a little more fancy, I guess, on how we do that. But
yeah, it's a pretty tough problem to solve, though, to try to provide a system that's dynamically sensible and will scale up and do the right thing, but also try to jam in some admin control to force things to happen. Yeah, it's not to say it can't be done, but certainly our first release of this feature, we did not want to hold up to try to get that to work in a nice way.
I guess I'm getting all these gaps because I've been playing around with the scaling. I have to, I'm not saying my demo is infallible. I know that the partition queues are working as expected, so maybe I have some logic somewhere in my a logic problem in my demo. No, there they go. They've kind of reset. Oh, but my queues are way too. Oh, it's because they're slow. That's why. I'm like, why are my partitions filling up so much? I wanted to show that we can actually pump quite a bit of messages through my queue here. Running Roach, one more comment here. Like use participants pulling the demo to dynamic Ruby on the thing. Right. So obviously, if you have the ability, each of these partitions is essentially a exclusive queue on the broker. So, just like I have a video on YouTube talking about the reactor pattern, where basically I have a single app listening to its direct messages, but you can use it with not a exclusive queue as well. And then it's multi-threaded. Like internally, it does scaling or kind of distribution. So you could obviously build an app that I know I'm connecting to one partition, but it can maybe split that out into multiple messages. There could be, I don't know, another partition queue sitting behind that guy, for example, maybe. There are multiple ways that you could kind of, I guess, make it so that you can load balance even further. Let me just get rid of these guys. Change their slow scaling to 0. Yeah, partition stats. You could use the partition stats. I guess you like the KEDA autoscaler definitely looks at the queue depths to make sure that it's not filling up too much. That's its probably main metric. But you could look at the egress rates as well. You would have to know something about your consumer behavior on average, right? Like you're saying at minimum, each consumer should be doing 20 messages a second. So if you ever fall down past that metric, then maybe add more subscribers, or maybe kill that one consumer and let it flip over to a healthier subscriber, for example. So there's lots of things you can do in terms of metrics, both from the broker pulled with SEMP, as well as at the application layer, and they could be kind of reporting those stats in that you could be listening to as well. Mohammed has a question here. Oh, right, we're getting towards the end here, guys. Does Solace have patterns for aggregators in data from instrumentation? Maybe, not that I know off the top of my head. I don't know if Ed, if you have something to say to that, but I would. Nope. Yeah.
Not sure of anything to add there.
Yeah, I've been at Ed's been at Solace 19 years. I've been at Solace 12. There's still quite a few things I don't know about Solace, especially some of the customer use cases and patterns. I would say head over to solace.community and sign up for an account and ask your question there. There's a ton of smarter than me people that hang out at Solace community and can answer some questions. We definitely have people that do IoT use cases. We've been working with a number of companies, both in manufacturing, connected cars, all sorts of things that do MQTT messaging for IoT devices. So that's the best place to ask. I don't know. I love being put on the spot, but I don't have a good answer for you. Sorry, Mohammed. But yeah, head over to Solace community, and link is right there. Solace.community, and ask your question, and hopefully you'll get a good answer. One last one from Running Roach here before we go. Admin level control would really bring this to another level when the broker and the apps can work together to really deliver performance. Right now, Solace plays catch up. Yeah. Okay. Fair. Yeah. Well, I mean, as I know you're a customer, just make some feature requests to your friendly local Solace account team, and they'll be passed along to our product line management. I do know that there are some things being considered, such as where, I don't know, the partition queue the partition key could be automatically chosen from a existing parameter, right? Like in IoT devices, just talking about IoT, maybe you don't have control over what topic they're publishing on, or maybe even what key they're listening or publishing to. But you might want all messages from the same device to go to the same consumer, right? So maybe the device ID could be the partition key. Wouldn't it be nice if there was a way in the broker that you could say, hey, I want to use, just use the publisher ID as the partition key. That could be a cool use case. And I think that's something maybe we're considering. I'm sure there's a couple others as well, but yeah, if you have suggestions on what we can do different or what we can do better, please pass it along to your account AMs, and they'll pass it to headquarters. So, Running Roach is answering Mohammed. Thanks. We built an aggregator in the apps because the app knows the message is the best and can request aggregation from the publisher. Right. Solace is just the transport. We don't keep track of we're not a use case. We're a generic use us for anything type thing. So sometimes, yeah, you're gonna have to build some business logic into the apps themselves. Using Solace to communicate, just like my demo, I'm passing guaranteed messaging, direct messaging. I'm using heartbeats, sequencing, all that kind of stuff can be sent to Solace messages. So your subscribers, if they had to do some additional stuff, could reach out and publish other messages for stuff. So anyway, Geary, I'm supposed to hang up. I have one more question. All right, this is the last question, everybody. Fantastic demo, Aaron. What is the performance impact due to classic issues around partition churn, if applicable, or imbalanced consumer behavior? Partition churn. So I think you mean like client churn, right? When clients, you shouldn't be scaling your partitions up and down is kind of essentially it's a kind of almost stop the world type event, right? You want to stop your publishers to make sure that the partitions are drained. You want to pause everything while you change the number of partitions. You would do this in a maintenance window. Consumer scaling should be done anytime, right, Ed? Like we should be able to just add or remove. Yeah.
Absolutely.
And so one, I don't know if I called it out specifically, but you'll notice that during that rebalancing period, messaging is just continuing to go, right? We're not pausing during that. Then during max handoff, only the partitions that are getting reassigned get paused. So only the things that are changing get kind of paused. And so unlike other brokers during a rebalancing kind of event, they might have to go back to their partition could get changed completely, and they might have to go back to their last known checkpoint, and everybody kind of gets reassigned. I don't know if that's the way that Kafka works anymore. I think they have smarter ways of doing partitioning now. But yeah, only the partitions that are getting changed kind of get paused. And if your max handoff is quite small, that pause is going to be quite small.
Well, again, it's also the max time, right? So if your messages are acknowledged quickly, then the pause is quite small.
That's right. So it should be like you'll notice in playing with this demo, if you do, that when you add a new subscription or add a new subscriber, if the message rates are quite high, there will be a period just during that max handoff where those partitions will kind of like buffer up, and then you'll get the new guy will become active, and then shroom, it'll just drain them all down. And so you'll kind of see that behavior kind of live on the demo. Imbalanced consumer behavior, it's if you have one consumer that's slow, you might have to add quite a few more subscribers in order to get those partitions spread out enough that one slow subscriber is able to keep up with its message rates. But this is where instrumenting the clients as well as just the broker, to kind of keep track of, is this client healthy? Kubernetes, what is it? Cattle, not pets. Is that the expression? Is that, yeah. You want to, if something's going wrong, chop them off, let a new one take its place. Kind of instrumenting your apps could actually be useful as well in terms of kind of helping keep your overall distributed application healthy. So, yeah. I think that Ed, we're way over the hours. I'm sure you got meetings and more important things to do. So I'm just going to go ahead and I think we're going to have to call it there. I hope people go and try this demo. I hope people download it and give it a try. And at least, I don't know. Yeah, I hope they do. How'd you do, Ed? Did you have fun?
It was great. Great. It's always good to see your stuff, Aaron. It's never disappointed for sure when I see one of your demos.
Well, they take too long. That's what I'm disappointed at. I wish, I spent probably the majority of the summer working on this demo, and anyway, yeah, it took longer than I wanted it to, and so I'm hoping that people
definitely as a fellow demo writer, I know that the devil's in the details, and you can't just whip something off that works well.
And it's the GUIs. It's tweaking the GUIs to make it just right. Oh, why'd that ball fall through that hole? Oh, we didn't get to see your demo. Oh my God. All right. I'm gonna post some links afterwards. It is still online somewhere, right? You can just use it for. You can use it on your own, right?
Yeah. It's there are videos as well. I think I don't know if there's any public videos about it, but. It is another.
Do you want to show it quickly for people that are sticking around? Do you want to share your screen for 5 minutes?
Sure, I'll do.
I don't know if you have to run, but I'd be more than happy to have you kind of demo it really quickly here.
Let's see here. Yeah.
So Ed was inspired. Well, I'll let you do your own spiel. Here, let me just add you to this. Add your screen here.
Yeah,
All right.
so it's another way just to see things going on. This is sort of
Very
it
visual.
was inspired originally by the game Portal, which is a Valve game where you can create these two holes in the walls and things go through them. And in this case, it's a way to show you how in this particular case, it's showing different queues. We've
Yeah.
got exclusive, non-exclusive, and partition. And again, this is like, well, I said it before, you can have the same messages go to 3 different queues, which is what's
Mm-hmm.
happening here, of 3 different types. So the exclusive, you can see, these
Only one.
represent 2 consumers. In an exclusive queue, they all go to 1 consumer. Non-exclusive queue, like I said, it round robins between them. You can see the colors represent the keys of the messages, and you can see like it's green ones up here and green ones down here. Whereas partition queues, you'll get the colors will be funneled off to be only on one partition. So all the purple ones are up here, green and yellow are here, green and orange, and whatever. So just again, it's a way of just visualizing different things. And in this case, it's a general tool to show different types of stuff. So you can, like, here's another one I like that.
Oh, I haven't seen this. This is new.
So this is showing topic routing.
Nice.
So again, if you start up here, you can just see, so each ball has this topic on it. Demo ball, what color it is, what its radius, and is it coming from left to right? Okay. And so you can see a specific topic here is it's just saying I want all the red ones of 20 radius and coming from the left-hand side. So it's only getting 1 ball. Whereas over here, you might say, I want the balls that I don't care about the color, so it's start out there, but it's radius 14, so that's the small balls, and I don't care what side it comes from. And so it's getting pretty much all the things. This one shows you a topic filter we can do on a queue. So it's saying, give me all the balls, except don't give me the red ones. And so no red ones show
negative up. Subscription exception. I was just playing with those like last week. Available for queues only, though. So one thing.
It's only on queues, So this was connected to a queue. So anyway, I mean, this is just again, it's a quick way to visualize how things are moved about. And this is all within one browser, but you could actually run multiple browsers and have balls go between the browsers or whatever, because it's just going over normal Solace messaging in the back end.
Yep, having that distributed communication in the back end means that most of our demos you could run in multiple places quite easily. I mean, that's what Solace is built for, right? Is distributed applications. So it's not all. You could have obviously faked that by just running everything in the browser and just pretending that it's talking to a Solace broker, right? But it's not
legit.
It's you can go look on the broker at the client connections. Yeah. Ed, we got some props here. Yes, I love your ball demo. I think it's awesome. I actually put a quick snippet of it in my YouTube video that I posted yesterday. So people, if they don't want to watch this long rambling version, if they want to watch the quick, short, sharp one, they'll see your ball demo in there, and I give you props for it. So yeah, awesome. Thanks for showing that. Yeah. So everybody, it is way past. We're at the it's a quarter after here for me. I'm sure, Ed, thank you so much for being here, for being my co-pilot, for not stressing me out with anything and answering a couple of good questions. I hope you had fun. Any last words?
Not really. Just happy to be on here, and keep up the good work, Aaron.
Thanks. And thank you all for watching this. I hope you're still out there at the end, or if you're watching this on YouTube later, thanks for checking out the replay. I will be back next month, end of September. I don't know what my topic is going to be yet. Actually, I'm sure Mark already knows what it's going to be. I think it's going to be our new connectors, actually, our new connector framework. I think that's what it's supposed to be. Anyway, stay tuned. I'll be announcing it on solace.community. If you have questions about today's demo, or anything, find us there. Solace.community is where we hang out. And thanks again, Ed, for watching. I hope I love demos, and I'm happy that I'm actually sad nobody got that music at the beginning. But go watch Second Reality by Future Crew, everybody. All right, thanks, Ed. Talk to you later.
All right, bye-bye, everyone.
Bye, everyone.